Let's start with the basic premise: energy is transferred when work is done. This happens when a force acts upon an object, causing it to move. The key here is the interaction between force and movement. But how do we quantify this interaction? This is where our equation comes into play. W equals F dot D equals Fd cos theta. Let's break this down. W represents work. It's what we are calculating. F is the magnitude of the force applied, and D is the displacement, essentially, how far the object moves. But there's a twist: not all force necessarily contributes to work. This is where theta, the angle, comes in. Theta is the angle between the force applied and the direction of displacement. The term Fd cos theta might seem complex, but it's simply a way of calculating how much of the force contributes to actual movement in the intended direction. The cosine component is crucial because it determines the effectiveness of the force in doing work. When the force is aligned with the displacement, cos is 1, meaning all the force contributes to the work. As the angle increases, less of the force contributes until it reaches 90 degrees, where cos theta is 0, meaning no work is done in that direction. This equation also illustrates that work is a dot product. This mathematical term means that we are interested in the component of the force that aligns with the displacement. This is why only forces or components of forces that are parallel or anti-parallel to the displacement result in energy transfer. Now, let's talk about units. Work is measured in joules, which is the same unit used for energy. This might suggest that work and energy are identical concepts, but there's a subtle difference. Work is not just energy, it's the process through which energy is transferred from one system to another. It's the mechanism of energy movement, not the energy itself. Thank you for your attention. Don't forget to like and subscribe.